So let's give this a go. Now, there's two twists to this problem, okay? Which is somewhat cool because question 5, I think it's like the first 3-unit question in the paper, being that it's a combined paper, but anyway. The first twist is that you've got different bases, okay? So you have to do something with this in order to get these two logs talking to each other, right? Different bases, you can't do anything with it. Just like with fractions, if you've got different denominators, they can't talk to each other. If it's surds, if you've got different things underneath the square root, can't talk to each other, right? So what are we going to do? Got to change the base. The question is how. So how are we going to change the base? Okay, so remember, how does change of base generally work, okay? If you've got, oh, that works. How am I doing that? That's good. If I take this, okay, and I want to change its base, all right? The idea is that this A will become the log on the bottom of my fraction, and the B will become the one on the top. And you can pick a new base, you can pick whatever you like, okay? So in your calculator, you might pick log base 10. Okay? Or if you're lazy like me, you don't want to write so much, you might pick a natural log, so that's base E. Okay? But the point is that in this case, what base are we after, right? Well, I'm going to change. Sorry? You can choose either. It won't matter eventually. Actually, I think one is better than the other. I think base 2 would be better. I think. I suspect. You'll see why later. That's right. The idea is I'm going to choose base A. No, base B. I want to change the base. So this is what I'll get. Okay? So can you see what I've done going from here to here? I've chosen a new random base. It just happens to be one of these other numbers. And so this part here just becomes 1. Okay? Just happens to be. Alright, now, how do I use that here? What did I just say? Base 2 is better, right? So I'm going to leave this log base 2 of x out the front. I'm going to change this one. By changing the base and switching it around, it's going to become reciprocal. That's this 1 over business. Okay? So I'm going to get 1 over log base 2 of x. Okay, now this is better, but it doesn't look much better, right? Because what can you do with that? You can monkey it around. These things don't mix very well. What are you going to do? Okay? And so this is the second challenge. You need to turn a log question into a quadratics question. Okay? So you cannot avoid multiplying through by log base 2 of x. Okay, so this is what I'm going to get. Now, a lot of you actually did this, but then you thought, oh, that squared term out the front, I've got to be able to do something with that. And you thought there must be some log law that I'm forgetting, or you used some other log law in the wrong way, like maybe you put this 2 out the front, which doesn't work. Okay? The key is to actually leave it like that. Okay? This is a quadratic equation. It'll make it a little more obvious. You've got log base 2, oh no, I turned it, oops, of x squared minus that plus 1. So do you remember when we were doing, or when you were doing last year, equations reducible to quadratics, right? So you could write this as, if you let u equal log base 2 of x, okay? This is just a standard old quadratic. Okay? Does that match up? Yeah? Yeah. Okay, yeah. When can you move the 2 terms? This is probably a better question. And the answer is when you've got the power inside the term. It's called the argument, actually, right? So that you can bring around to the front, okay? But log 2x multiplied by log base 2 of x, they don't mix. Log terms, remember the log's about time, right? So you can add time and you can subtract time, and that works. But multiplying time is not anything meaningful, okay? So when the whole thing is squared like here, you're just stuck, okay? All right, now, you can do the substitution. You don't actually need to. You can launch straight into quadratic formula because you can see it doesn't factorize very nicely. And all you need to say is log base 2 of x is equal to. Okay, now, go for it. You tell me what to write. How does quadratic formula start? 9. Okay, so minus b plus or minus the square root of 77. B squared minus 4ac. Okay, yep. All over 2a. Okay? So you've got 9 plus or minus the square root of 77, 1, 2. Now, log base 2 of x, okay? Now what do I do? What do I do from there?
X equals 2 to the power of 30.
Okay, yeah, so this is, remember this is two values, but a law equation is just an index equation in disguise, right? So I just need to say that this type, or both of them, really, I'll write those separately, minus or, okay? From this line I read off that x is equal to 2 to the power of these things, okay? 2 to the power of 9 minus root 77 on 2, and, sorry, 2 to the power of 9 plus root 77, which is gross, but that's the answer, okay? And that's why I think they asked you to approximate, right? Yeah, 2 decimal places. So you can get your calculator, and that's where you'll get your values from, okay? Ta-da! Do be cautious when you're popping this in your calculator. Watch out for your brackets, particularly when you go up in the index and you've got square roots, and you're going to have at least 2 sets of brackets on that to make sure you get it right. Okay? Does anyone